Okay, guys, we're going to try this. We're going to try this right with synthetic division. Okay, we're going to go right to synthetic division with this example. This is a fifth degree polynomial, which admittedly would be quite a bear without this synthetic division. So we're just going to show you how streamlining this can be with the synthetic division. Okay, so I've put down my coefficients. This is a fifth power. One round of synthetic should take it down to uh, fourth power. Then I'll have to do another round of synthetic to bring it down to a quadratic or a third power, then a quadratic. So let's see what happens. I'm going to presume one's going to work. Again, even if it doesn't, I'll know because I won't get a zero here. So I'm going to bring down one. uh, the first term. 1 times 1 is 1. Add is 8 times 1 is 8. That's 23. 23 times this is 23. That's 28. Times 1 is 28. Adding there is leaves me with 12 times 1 is 12, so that gives me a 0. So now I know I got a factor. I've got I've got one factor, which is x minus 1. Okay, the intercept 1, so the factor is x minus 1. I'm now going to start another round of synthetic division. 1, 8, 23, 28, 12. I'm going to try 2. If it fails, I'll know because I won't get a 0 here. 1, as just the first number coming down. 1 times 2, 2. 10, 20, 43. It looks like it's not going to work because it looks like the numbers are getting bigger and bigger, right? 46, it's not going to give me a 0, so I'm going to abandon it at this point, and I'm going to try negative 2, okay? 1 comes down, negative 2, okay, it's just 6, that's negative 12, okay? Negative 12 and 23 is 11, negative 22, and that's 6, and that's negative 12. So I'm good. So now I got another factor. I got the factor x minus negative 2, x plus 2. Okay? Now I've got this initially was a fifth power. This brings it down to a fourth. This brings it down to a cubic. One more round of synthetic division. Okay, bring down the coefficients 1, 6, 11, 6. Okay. Um, Obviously, here, okay, we would suspect we have to try a negative. Okay. Um, because all the terms are positive and they're never going to zero out. So I'm going to try the negative 3. Okay. Put that out there. Okay. 1 comes down times negative 3 is negative 3. Add, it's 3 times negative 3 is negative 9. Add is 2 times negative 3 is negative 6. I'm there. I'm right there. I've got my factors now are x minus the negative 3, x plus 3. Okay, so look, I'm just about done inside of 4 minutes on this. I'm agreeing that this expression is going to factor as x minus 1, x plus 2, x plus 3, and then the quadratic of x squared plus 3x plus 2, which of course will factor as x plus 1 and x plus 2. Okay, so I'm fully factored now. I've got a multiplicity at x plus 2. So I have x minus 1, x plus 2, the quantity squared, x plus 3, and x minus 1. And I am now fully factored, ready to graph, and I trust that won't be a problem for you to graph because you know it is initially a fifth power polynomial, and now it is fully factored, okay? Now, of course, what you could do is you could just verify that. In fact, that's exactly how I got it, was from my calculator. I took my calculator and I asked my calculator to expand a certain expression, okay, which was a product of a couple factors, as you can see here. And in expanding that, of course, it turned it into a fifth degree polynomial, which was the one I gave you from the start there. So, okay, you could, if you wanted, you could make up your own for practice with that, okay? But that's the beauty of the synthetic division, okay? Just wherever you stop on one round, it becomes the starting point for the next round, and every time you're knocking it down by a degree from the fifth to the fourth to the third to a quadratic, which then hopefully factors um, as usual. Okay, so there you go. Practice on those problems from the worksheet. Use synthetic division if you're comfortable with it, but you really should see the benefit and see how it streamlines the process for you. Okay, there you have it.